So welcome to the learning target number 4 and 5 video. Okay, we started this on page number 10 over the weekend, and just to recap, I can identify each part of an algebraic expression, so variables, terms, like terms, coefficients, and constants. And then ultimately, the real importance here is that you can simplify expressions by combining like terms. Okay, so as we did these first three, and we talked about what a term was. A term is anything separated by an addition or a subtraction sign. So 5y would be a term, 3 would be a term, 2y would be a term, 1 would be a term, and 1y or just y. Okay? Then we talked about how like terms are when you have a variable term. If they have the same variable, they're going to be like each other. Okay? And then we know that constants are always like. Okay, constants, remember, are numeric terms. Okay, so what I have underlined or circled in red, that is a numeric term. If you are still struggling with this right here, being able to identify, guys, that it's really just, it's more of a memorizing thing than a learning thing. Now, when you get to simplifying, that's more of a learning and an understanding. But really, knowing what a term, a like term, a coefficient, a constant, that's just memorizing. We've got to get it. So go back and watch the old video if you feel you need to. Okay. All right. Now, first we're gonna keep practicing. We're gonna do a couple more of these. I'm gonna go a little faster today on this video rather than on the last one. I went relatively slow. Now, the first thing, I'm just gonna take off these exponents for now. Okay. So just for you, just kind of either ignore them or whatever. I just want to make sure I'm not ready for exponents yet. We'll do those down on number 5 and 6. So first of all, I look at the t, and I immediately see a plus sign, and a plus sign. And I said anything that's separated by a plus is a term. So that means my terms are 9t, 12t, just t by itself, or 1t, right? And then finally you have 1. Okay. Now I always like to skip and go to coefficients next. Remember, actually I would like you to write this. Remember, terms, you have two types of terms. You have a variable term, which is a term with a variable, and you have a numeric term, which is when you have a term that just is the number by itself. So I'm going to highlight this in green. That's a numeric term. Okay, I'll highlight the other one in blue. So a variable term, well, that's a term with a variable. So that would mean that's a variable term, that one, and that one are variable terms. It's the only two types of terms you can have. Okay. Now we go down to coefficients. Coefficients are part of the variable term, and they are the part that's directly in front of the variable. So that's going to be 9, it's going to be 12, and then remember, it's going to be the 1 in front. Okay? So coefficient, just the variable, just the number in front of the variable term, or in front of the variable. Okay? Constants, those are the terms that are just numeric. So that I said that's a synonym. Those are synonyms. Numeric term and constant, same exact thing. So that means my only constant here would be 1. Okay. Now let's talk about like terms. I look up here and I say, okay, do I have any variable terms that are like? Yes, I have 3 right there. I have 9t, I have 12t, and I have t. And I like to put them in parentheses just to group them and show that. Okay. Now I only have one more term to even deal with. Can it be like anything else? No. So this is our only like terms. Okay, now we've done learning target number 4. Simplifying, that's learning target number 5. Okay, so this is where we're going to take this and we are going to simplify it. So we're going to take those like terms that I have right there, and I'll try to find a different color to highlight here so it doesn't turn into a big mess. Those terms are like, that's like, and that's like. Okay, and I'm going to combine them. I'm going to put them together so that I don't have to have 3 separate terms. I can just make them be one term. Okay, now remember, 9t really means t, and so on 9 times. This means 12, or I'm sorry, t plus t, 12 of them added together. This would just be 1t. So doesn't it make sense that I can combine them and say, okay, well, I have 9 t's, I have 12 t's, and I have 1 t's. So I can do 9 plus 12, which is 21, and then I can add on 1 and get 22. So I know that these, what I have highlighted in yellow here, these like terms right here, that would simplify to become 22t. Okay, 22t. Okay, now I've got anything I haven't used, I converted that right there into that. So those got simplified down to become that. Now I got to tack on my last part of it that couldn't be combined because it's just by itself, 22t plus 1. Okay, let's do the next one here. Here I have a 11m, that's my term, 11m, comma, 4m, 5, 15m. Okay, go down and do coefficients first. Coefficients are the number directly in front of the variable. So I would have 11, I would have 4, and I would have 15. Okay, it's the number in front of the variable term. So 11, 4, 15. Constants are just when they're a numeric term, which I see the only numeric term would be right there. So that'd be 5. Okay, now I know that my like terms are anything that have the same variable. So that's 11m, 4m, and 15m. Those are definitely like 11m, 4m, and 15m. Okay, and again, I've basically said that these right here are all like each other, right? So we only have one thing left, one term left. Well, if there's not another constant or not another term, then you can't have any more like terms. Okay, so now we're at the key part here. We're at the most important part, really. It's really the application of this, and it's taking that expression 11m plus 4m plus 15m and putting all those m's together. So 11m's plus 4m's. And I like to think of these, put an animal with it, monkeys. Okay, think of it as 11 monkeys and 4 monkeys. You put those together, you have 15 monkeys. Okay, you add it together with another 15 monkeys, you all of a sudden have 30 monkeys. And I'm fine with that. You know, use names to help you do it. And then we look and say, well, everything that I have highlighted in yellow there, it became that right there. They have the same value. And then I need to put on my plus 5. Okay. All right, last thing here. Now we're going to leave those exponents on there. This is where it gets a little harder. Your terms are still 2y to the 5th. Anything separated by a plus, 5y, y to the 5th, and plus 5. Okay. I go down to my coefficients, anything in front of a variable. So right there, and right there. So I know my coefficients are 2, 5, and hopefully you know that there's a 1 right there in front of that one. Okay, there's a coefficient in front of every variable, and if there's nothing showing, that means it's a 1. Now we talk about constants. What's the only numeric term up here? It is 5. Like terms. Now, this is where it gets a little bit weird, and this is more next year than this year, but I think we got to start seeing it now. Yes, the variable is the same. Okay, I want to make sure I go real slow on this, and I want you guys to grasp this. Yes, I have a y. Yes, I have a y. Yes, I have a y. Okay, but this exponent makes all the difference in the world. Okay, so I want to make sure that you guys don't think that just because it's a y and a y, they're the same. It is not. Okay, 2y to the 5th right there, that's going to be like y to the 5th. So not only do they have to have the same variable, they got to be to the same power as well. Okay, whereas up here on all these, I mean, these don't have they technically have an exponent of 1, is what it means. So do you see why we would be able to combine those? Because they all have that exponent of 1. Okay? So they must have the same exponent. So that means the things that I have in yellow, those are definitely like 5y. That's its own thing. You can't combine it because, again, you would be breaking PEMDAS. Okay? 2y to the 5th, you must do y to the 5th before you can start adding the amount of y's you have. Okay, so that means my like terms would be 2y to the 5th and y to the 5th. And then these are certainly not like because one's a variable term, one's a numeric term. So that's all I would have. So combining these now, I would look and say, okay, how many y to the 5th do I have? I have 2 there, I have 1 there. That means that I have 3y to the 5th plus 5y plus 5. Okay, there is nothing that I can combine what's in green right there with. Okay, I know that might be kind of troubling for some of you right now, but hopefully we'll do another one and it'll all make sense. Okay, so that's what the exponents are all about. Here, let's go ahead and put a 2 there, and a 2 there, and a 2 there. Okay. Now my terms, I'm not even going to write them out. 4m squared, 5m squared, 3m squared, and 2. Those are my terms. Just put a comma in the place of where the plus is. Okay, now coefficients, number in front of the variable, 4, 5, and 1. Constants, okay, numeric terms, I have a 3 and a 2. Okay. Now I'm going to simplify this expression. Now here's the deal. Well, first I got to do my like terms. Now I look here and I see, okay, I see an M, I see an M, and I see an M. But you've got to check to make sure they also have the same exponent, do they? Yes, they do. So absolutely, those would definitely be like terms. 5m squared and m squared. Okay? And those are my like terms also. Okay? Those constants, because constants are always like terms. So now we're ready to simplify. So anything that's in parentheses can get put together. I have 4m squareds, I have 5m squareds, and I have 1m squareds. So that would be 4 plus 5 is 9, plus 1 is 10m squared. Then I have these constants right here. I have 3 and I have 2. Put them together. You get plus 5. Okay? Hopefully this is starting to all kind of make sense here a little bit, I'm hoping. Okay, let's practice some of these. Here we got x plus x plus x plus x plus x. Well, you guys know that repeated addition can be shown with multiplication. So that's 1, 2, 3, 4, 5. So that'd be 5x, right? 5 times x. Another way to think of this, remember, each one of these has a coefficient of 1. So if you have 1x, 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 doesn't that mean you have 5x? Okay. Next one. I look here and I say, okay, what do they have that's like? I look and I say, okay, they have a y, and a 6. Can I put those together? Absolutely. How many y's would I have then? I got 1y and 1y. That means I have 2y. Remember, you can show multiplication, addition as multiplication. And then you would leave it as 2y plus 6. I want to make sure we're not doing this. This is wrong. Please write it because sometimes it helps to see what's wrong. Some people want to do this, and it happens every year, so don't think you're the first one. I get people that get this, and they want to all of a sudden make it 8y. Okay? That is absolutely wrong because one of them is a variable term, one of them is a numeric term. You can't combine those. They're not like. Now, if this had a y on it, that would be absolutely correct, but it doesn't. Okay? So it stays just like that. Okay? Here we got m, m, m. I would say, yep. Those are like each other. They got the same exponent. They got the same variable. That means I have 3m. And then I have the constant 5 and the constant 4. Put them together, you got 3m plus 9. Okay. Here we go. I want everybody to make that a plus right there. So I got n, 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 n. Okay, so 1, 2, 3, 4, 5, 6n. Just combining like terms. Plus, what's 12 plus 8? 20. Okay. All right, now we'll get into a little geometry here, okay? So a square has length x centimeters. Find the perimeter. Now we know the perimeter is when we add up all the sides of a certain figure, okay? So we know that this would, yeah, sure, it'd be x plus x plus x, okay? But the simplified way to say this would just say, oh, it's just 4x. Because there's a coefficient of 1 in front of all these. And if you have 1x plus 1x plus 1x plus 1x, that would mean you have 4 x's. So that means the distance would be 4 times whatever that distance is, which makes perfect sense. Okay? The figure shows a trapezoid. The length of each side is given as shown. Find the perimeter. Okay? Well, we know we just add up the sides, so we know it's w plus w plus w plus 10, okay, and we have w, that we would put those together. Remember, repeated addition would just be multiplication. I have 3 of them. I'm just going to make that 3w plus 10. Now keep in mind, I'm not allowed to say, okay, the perimeter is 13w. You can't do that, okay? That's wrong. You cannot combine because they are not like terms. That's a constant. That's a variable term. Okay, so no, it couldn't be 13w because they are not like terms. Again, guys, you can never break PEMDAS. If you knew that w equals 2, that would mean that 3 times 2 plus 10 would it be okay if you just went ahead and added 3 and 10? That's essentially what you're doing, right? By doing 13W. So that's why it's wrong. You got to follow PEMDAS. Okay? All right. We'll just keep rolling here with all these. Okay? We're going to skip that one for now. Here we got 9T, 3T, and 4T. Okay? They're all like each other. So that's like, that's like, that's like. So you know your variables of T. 9 plus 3 is 12, plus 4 is 16T. Right? Here we got 5T, 1T, and 4T, all alike. That's going to end up being 10T. 5 plus 1T is 6T, and 4T. And real quick, want to show you the reasoning. Once again, 5T would be shown as T plus T. I don't want to use T's. Let's use, let me go down to this one. I'll show you what I mean. This one right here, I'll do this in red. 7W would mean W plus W plus W plus W plus W plus W plus W. Okay? Now I'll do plus because we're adding 2W to that, so it's going to be plus W and W. Right? And then the final one here I'll do in green, and that'll be 6W, and that would be, move over here a little bit, plus W plus W plus W plus W plus W plus W. Okay? That's what it would be. Alright? So all I did was I broke down 7W to make it that. Okay? Obviously, repeated addition is multiplication. I did 2W in blue there. That's 2 W's, right? And then I have 6 W's over there. And here's why we can combine like terms. Sure, the answer is 7 plus 2 is 9. Plus 6 would be 15W. But the reasoning behind it is this. To show repeated addition, we can just multiply. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we know that we can, instead of adding all those W's, we can just multiply it by 15. Okay? Should be starting to sink in, I hope. I hope that you're starting to see it and start to realize that it's actually pretty easy, I think, now. If you want to do some extra practice, continue on with these. Okay? And only you know if you need to. Okay? Actually, you know what? I'll just leave it up to you. Okay? If you want to practice some, go through and practice these. I'll tell you if they're right tomorrow if you want to come and check with me. Okay? All these are pretty good. Okay? All those 28 through 18. Well, that didn't really make sense, but all these. Okay? I don't think it's necessary that I go over every one, but if you're somebody that does need that extra assistance, that extra practice, I would highly encourage you to please try to do that. Okay, here we'll talk about this one here. Okay, a book has a length of B plus 2 inches. Okay, now again, you guys got to quit thinking in terms of a length of something just being one number. Okay, you're at the point now where you're going to start seeing stuff like this. We all know that B plus 2, that has some value, but we don't know what that value is until we know what B is. Okay, so you got to understand that that's what that means. Okay, now we're gonna find the perimeter of the book here. So we know the perimeter means adding up all the sides, so it's gonna look like that. Okay, so you're gonna add up all these sides. So you're gonna have B plus 2 plus B plus B plus 2 plus B. Okay, B. B, B. See all those like terms right there? They're all B, so you can combine like terms. That's going to mean that the distance is going to be 4B. And then you have these constants you must take care of. You have a constant 2, a constant 2. That's going to be plus 4. That is the perimeter of the book. Again, it's not about just finding an exact answer anymore. It's about finding an expression that if you knew what B was, you would know the perimeter of that book. Okay, I knew that this right here was B plus 2 because I knew that was B plus 2. I knew that this right here was B because I knew that was B. And then I just added it. Okay, this right here is representing this one side here. And then I got B plus 2 over here again. But you can take the parentheses off because all you're doing is adding. Okay, and adding is commutative. Okay, all right. And then this one down here, this would be the same way. Adding up that would be okay. Right there, that's Z, okay, we're finding the perimeter. z plus, I know the distance here is z plus 4. Take the parentheses off because it's just addition. It's addition. So there's you can get rid of them. If there was multiplication and other stuff happening, then you would have to make sure the parentheses stay. Like if I said z times z plus 4, you'd have to do z plus 4 first. But because it's adding, it just doesn't matter. The order is going to remain the same. Okay. So let's keep going here. Plus, now we're going to do this length plus z plus 3. By the way, those are my z's. I know everybody always asks. I don't want them to look like 2's, so I always put that through there to make it look like that. Okay, and then finally we have this last side, which is plus 8. So I look through and I say, okay, is anything alike? I say yes. There's a z. There's a z. There's a z. Okay. Now I see a constant 4, a constant 3, and a constant 8. And I know that anything that is like I can put together. Z and z makes 2z, plus z would make 3z. Plus, and then I got 4 and 3. Put those together, what do you get? 7 plus 8 would be 15. So, I think you guys are going to feel pretty good about this after we go through it tomorrow. I think you're going to think it's actually relatively easy. But the biggest mistake, once again, just let me do this one more time. When you have it here, you cannot make that 18z. That's the mistake every year. Students make it over and over and over again. So let's not do that. It has to remain this because they're not like terms. This has a variable, this does not. Numeric terms and variable terms can never be like. Thanks, guys.